1. So what we're talking about today is two main things that I want you to get out of this kind of lesson are, let me get my pen up here, are the product rule and the power rule. So we'll talk about the product rule for exponents. These three are examples of the power rule. There's just three different examples, kind of how they work and what they look like and all that fun stuff. And then we'll use some combinations at the end. So what is exponents? So this one says, write 2 times 2 times 2 in exponential form and evaluate. So what does 2 times 2 times 2 mean? Well, we can write it with an exponent and it looks something like this. So the 2 in this case is called your base, and that's going to be a word that I'm going to use a lot today. So just something to keep in mind, and this is called your exponent. So 2 cubed is what we say sometimes. So that just means that we're doing 2 times 2 times 2, and the last time I checked, 2 times 2 is 4, times 2 is 8. So 2 cubed, in this case, would be equal 8. All right, these are three that I just want you to look at really quickly. Just a couple different things. I'll show you this first one. So again, we have a base of 2, exponent of 6, which it looks like that. So we're doing 2 times 2. So it's not 2 times 6. That's not what we're doing. We're doing 2 to the 6th power, which means we're doing 2 times 2 times 2 times 2 times 2 times 2, which gives you 64. Now, this one and this one are very similar. You have to watch on Pearson specifically. That's why I want to go over this with you guys. How they kind of work things and how your calculator will work things as well. So at the very, very beginning of the year, we talked about order of operations and we talked about PEMDAS. So the P stands for parentheses and then exponents, and then we do multiplication and division left to right, and then we do addition and subtraction left to right. So for B here, the way your calculator will view it and the way that Pearson actually views it for your homework is it views this as -1 times 2 to the 6th power. Now if I go down my thing, if I go down my order of operations, I see a parentheses. I don't see any parentheses. I see an exponent. So in this case, it would do -1 times whatever 2 to the 6th power, which is, we figured out, would be 64. But then when we think, what is -1 times 64, I would say that that gives you -64, okay? Differently, this down here, what this is looking at is this is the quantity of -2 6 times. So they're looking at -2 times -2 times -2 times -2, sorry, 2 more, times -2. So what they're looking at is a negative times a negative is a positive, times a negative, so this is a positive, this is a negative, this would be a positive, this would be a negative, this would be a positive. So this answer gives you a positive 64, which I would conclude that C is your actual technical answer. If somebody came up to me and said, what is -2 to the 6th power, I would say positive 64. But just be careful. This is how Pearson does it. Just a heads up. Yeah, and kind of go from there. All right, so here's the product rule, okay? So this is what's called the product rule for exponents. So this says that if we have a base of a with an exponent of m and a base of a with an exponent of n, if we have like bases, what we're going to do is we're going to add the exponents, okay? So for example, 6 squared times 6 to the 5th will be 6 to the 2 times 5, which is 6 to the 7th. So we're keeping the same base and adding the exponents, okay? Yeah, so that's kind of the product rule. So what does this look like in real life? So A is kind of weird. I probably shouldn't have done this one as the first example, but I will. So what I did is I just did -4 times 3, which gives me -12. And then I have p to the 5th and p to the 8th. Because I have it, I can write it like this. I'm going to add those exponents, so I'm getting p to the 13th, okay? So this final answer here is -12 p to the 13th. Be careful on B. This one technically has a 1 here, so this should be m to the 5th, okay? So again, like bases, add the exponents. Go ahead and take a minute and try these. Oh, sorry, don't do this one. Do this one as 4 to the 5th. Sorry, it's supposed to be a 5. And then, yes, just try them for a couple minutes and I'll come back on. Okay, for c here, I think this does it for you. So I have z squared, z to the 5th, z to the 6th. I think when you add those exponents, I think you're going to get z to the 13th. I changed this one because I just wanted to do that. So I think this one is going to be 4 squared times 4 to the 5th, which should give you 4 to the 7th. And then this one down here probably tricked you. Sorry. This is kind of a trickster. So remember, this is called the product rule. So in order for it to be a product rule, these things have to be multiplied. So you're not going to get 6 to the 6th. You're not going to get 12 to the 6th. You literally just have to figure out what 6 to the 4th power is, which is 1,296, plus 6 squared, which is 36. So be careful when you're using the product rule. You have to make sure that you're adding. Or, sorry, you have to be sure that you're multiplying, not adding. Okay? All right. So let's talk about the power rule. This is power rule A. And the way I look at this is that I've got some base and some exponent inside my parentheses, and I'm raising it to another exponent. Now, this isn't the technical term, but this is the way I think about it. We're basically going to take this exponent and we're going to distribute it into that exponent, which means we're going to multiply them together. Okay, so like if I had 3x, remember when we distributed that in, that becomes 3x, right? Or sorry, 3 times x becomes 3x. So I think about it the same way. So here, when I have a base of 3, exponent of 2, and a 4, I'm distributing this 4 in there. So I get 3 equals 3 to the 2 times 4, which is 3 to the 8th power. Now, what does this actually look like? This looks like 3 squared times 3 squared times 3 squared times 3 squared, right? Because that's 3 squared to the 4th power. Now remember, these are all the same bases. So what am I going to do with the exponents? I'm going to add. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So I end up getting 3 to the 8th power. So this is kind of like a shortcut that you can use in order to get there. So if I'm looking at this one, I'm going to distribute that 3 in there. So I'm going to say that that's a base of 2 raised to the 5 times 3 exponent, which is 2 to the 15th power. And then here, that's a 4. So I think that that is a base of b raised to the 3 times 4 power. So that should be b to the 12th. Take just about 30 seconds and try these ones super fast. Okay, so this one really quickly, you're just going to distribute that in. So you're going to get 6 to the 2 times 5, so that's 6 to the 10. This one is z to the 4 times 5, so that's z to the 20th. Okay? So that's kind of power rule A. So basically what I look for is I look for parentheses. Okay, so if you see something inside raised to a power, you're going to use the power rule. This is kind of the next example of that. Similarly to the first one, this is an A and a B, so now we have 2 different bases inside our parentheses. We still want to raise it to that power. So in this case, I've got to take this 5, and not only do I distribute it to the P, but I also distribute it to this 2 as well. The most often incorrect answer for this that I would get is 2P to the 5th power. So here, I'm just distributing the exponent to the P, but I never distributed it to the 2 as well. So remember, 2 to the 5th is 2 times 2, which is 4, 8, 16, 32. So this one is technically 32p to the 5th power. Okay? So again, if I'm raising a product to a power by raising each factor, this is really the key term right there, to the power. So what do I mean by that? And I rewrite them. I write this as 2 squared, a squared squared, b cubed squared. So what's 2 squared? 4. A to the squared squared is a to the 4th, and this is b to the 6th. Okay, so again, this 2 I had to distribute not only to the a, which I got a to the 4th, and not only to the b, which I got b to the 6th, but also to the 2 as well. Okay, we're not going to do c here. This is ridiculous. So again, this one, negative 2 cubed. I'm writing it like that. Remember I talked about it on that second slide. With this one, it works either way, but that's the way that I would do this one, even if it wasn't. Yeah, because it's an odd exponent, regardless of what you. Anyways, excuse me. -2 times -2, I believe, was a +4 times -2 is a -8, and this is a to the 15th. So again, emphasis on taking the exponent, distributing it to your coefficient or your number in this case. Okay, so do me a favor, take a second, try this one. Oh, sorry, don't do the last one. Don't do C. I don't get what they're trying to do with C. I don't know. It's weird. Okay, so this one, I love that they did this. They didn't put the 3 in parentheses, but I love that they did it this way. Yeah, so you got that one. So that just becomes that. And I think they actually do 3 to the 5th, which is 243, a to the 10th, b to the 20th. And again, here. Okay, so what I was trying to say earlier, and I never finished my thought. Sorry about that. When you have a negative number raised to an odd exponent, you're going to get a negative. So even if we would have done, so what I mean here is that if I have -3 cubed, and let's say that we do 3 cubed first, right? So we're doing order of operations first, I'm getting -1 times 27, which will give me a -27. That will be the same if I do it this way, because a -3 times a -3 is a +9 times a -3 is a -27. So if you have an odd exponent, you're going to get, I mean, if it's negative and you have an odd exponent, you're going to get a negative regardless of which way you do it, like I talked about in the beginning of the video. Now, where you get into trouble is if it's an even exponent. So if this is raised to the 4th or the 6th or the 8th or something like that, that's when you're really going to get into trouble. So hopefully that makes sense. Sorry about the last one. And this is the very last one. So basically, remember in product rule B, we had 2 bases that were being multiplied together. Now we just have 2 bases on top. And again, distribute it to both. That's the key here. So when you raise a quotient to the power by raising both the numerator and the denominator, so this is like the key, I don't know what I'm trying to do, that's like the key there. So for instance here, this is going to be 1 to the 5th over 3 to the 5th, and then you get whatever that is, and then here it's 3 cubed over x cubed, which becomes 27 over x cubed. So again, sorry, I didn't mean to rush through that, but the power rule C is very, very similar to power rule B. Basically just says that, I mean, the way you think about it, if you have anything in a set of parentheses and you have an exponent on the outside, you distribute that exponent all the way in. So it goes to every piece. All right, so here, I would pause the video here and write this down if I were you. This is kind of a little bit of everything. So this is everything we talked about today. So it deals with the product rules. Remember, like bases, you add the exponent. It deals with the power rules. If you have an exponent raised to an exponent, you're going to multiply those or distribute it. I don't think that's technically the right term, but that's how I say it. And then whether you have, the B basically says anything you have inside those parentheses gets that exponent. And C says even if it's on top of each other, that gets that exponent. So hopefully that makes a little bit of sense. So what I'd love for you to do, and this is kind of the end all be all, we're going to do one of these again on Friday just to make sure you guys really have it. Go ahead and try these ones. I'll give you a couple minutes, or you can pause the video either way. Maybe pause the video, take a little bit of time, try these ones, and then I'll come back in a couple seconds and kind of walk you through them. Okay, so instead of me writing these out, I'm just going to have the computer do them because I thought they did just such a wonderful job with it, honestly. And so, okay, so A, distribute that 4 to both the 1 and to the 5, right? So that exponent has to go to both, okay? On the right side, that squared goes to both the 2 and the x squared, okay? So 1 to the 4th power, 1 to any power is just going to be 1. 5 to the 4th power apparently is 625. 2 squared is 4, x squared. So some people got that. Some people got 4 over 625 times x squared. Same thing. Some people got, what was the other thing I saw? I can't remember. But yeah, any kind of similar situation to that is what we're looking for. What was it? I can't remember the other one. It was like, yeah, I don't know. Oh, maybe it was 1 over 625 times 4x squared or something like that. Yeah. All the same answer. No big deal. For B, I like that they noticed that 6y could be your base in both of those. So remember, like bases, we're going to add the exponents, so they got 6y to the 7th, and so they just did that. So you could have done 6 to the 4th, excuse me, y to the 4th times 6 to the 3rd, y to the 3rd, and then saw that these are the same bases and that these are the same bases, and then go from there. Either one works. And this one is really the big one. If you got this one, then you understood this whole chapter, because we have here, so I love that they wrote it out individually. I'm not a big fan that they put this 3 inside in here, but like I said a couple minutes ago, odd exponents really don't matter, so I love that. X cubed, y squared cubed, x squared to the 4th, y to the 4th. Simplified as much as they could, ended up there. They noticed that I have a base of x there and a base of x there and a base of y there and a base of y there. I believe I can add those exponents together, so I'm good to go.